Hello, hello, everybody. Hope everybody's doing well today. We are going to probably finish up the water section today. I doubt I'll do two here. I think I'll just get this one over with, and we'll get on to the next section, which is the energy section, one of my favorite sections. All right. So let us go over human activities in the waterways. So water is one of the most precious resources and is renewable if we do it right. All right, we can take water off the water table and actually, condemn it to not being used anymore. Now we put it way down into little holes in the ground and say don't come back. But we need to start respecting that because we'll learn about water withdrawal and how wasting this fresh water, which is, we have the least amount of out there, is fresh water that is actually drinkable. We got to keep that very safe. So people have been drawing water at unsustainable levels and depleting many sources of surface water all over the place, and it is getting crazy. The construction of engineering waterways like dams and canals has altered um, an estimated 60% of the world's largest rivers. I mean, humanity has, you know, altered all the biomes and all the rivers just about out there. It's amazing. Okay. So you can see here the climate difference and other factors have created varying amounts of groundwater, surface water, and precipitation across the earth. So water is very unevenly distributed around the world. All right. So you got more than 100,000 um, cubic meters per capita per year. All right, up here in the blue. All right, a little bit less down here in the United States. Okay, a lot here in the wetlands of the rainforest. Okay, but all dry up here in the desert area. Okay, so the water is not evenly distributed, and that's due to a lot of the jet streams and the oceanic conveyor belt blowing all this water up here. Okay, hot air turning into snow and then gets saved in the tundra. Okay, so the distribution of the human population does not match the distribution of water creating areas either. Um, so we don't really uh, care. We always can import that water. We have the technology and engineering to get this water to the hard places out there. All right. So where we actually are um, living doesn't really affect water is not really a factor, but sooner or later it's going to become a big factor in our lives. So the majority of the fresh water we use is about 70% is for agriculture. That is the biggest user of water out there. Industry, for manufacturing stuff, about 20%, and then residential, us, is about 10%. And what I like, what I always kind of chuckle when I hear, when we have water bans or, the city's telling us to try to save our water. It's always the citizens that are first told to save on water, even though they are the least ones. But in today's industry and also in agriculture, they are getting charged for this water nowadays. So most of them are. All right. Whether or not that fee is reasonable, that's up for the politicians and the community to decide. So the increased demand for this irrigation has led to consumptive use of aquifers and surface waters, where they remove our water, but they don't return it. All right. So remember, this is recycling. This is a renewable resource, right? And they can take out more than Mother Nature can put back, and they can't magically, make this water appear in that aquifer after they use it. All right. So it is consumptive use. Okay. Non-consumptive use, such as hydroelectric dams, either does not remove or only temporarily moves the waterways for the sources. So non-consumptive, just backing it up, right, and trying to keep it there. An excessive withdrawal of surface water has led to many world rivers running dry before reaching the sea. All right, so the Colorado is one of them. In the southwestern United States, the Rio Grande along the U.S.-Mexico border, and the Chinese Yellow River. All right, all of them are running smaller and smaller, and sometimes running dry before they even get out to the ocean. And this drastically alters the ecology of the river's delta because there's been ripens. What we talked about ripen areas before, and ripens are right along the side of the waterways, and sometimes those ripen areas disappear, and because there's no water, they need a lot of plants, and there's some trees and things there. So if there's no water running down the river, they are not going to be able to survive. We also do what's called water mining, and that's the withdrawal of water faster than it can be replenished, and it's taking places in a lot of areas. So you can see these red areas are all overuse. And right here in the United States, this is the Ogallala Aquifer. All right, the biggest aquifer. I think this is one of the biggest aquifers in the world. All right, over here is another one. I can't remember what this one's called, but this is the breadbasket of the world, and this is the only reason why we're able to grow what we grow out there is this Ogallala Aquifer. All right, because remember, biomes are predicted by precipitation and temperature. Well, the temperature is great for corn and the wheat and stuff out there, but the precipitation is not. But we have this huge aquifer underneath here to help water everything for us. So that's a good thing, right? But we are actually withdrawing more than the Mother Nature is actually putting back. And the effects of the surface water depletion are very evident in the cases in the aerial sea. All right, so this is just an ocean. You know, we can't see what goes on in these aquifers. All right, but we can see what's going on in this aerial sea. We know what's going on because of satellite imagery and stuff like that. But we can see what happened with the aerial sea. This is what the aerial sea looked like in 1987, and in 2015, it's basically all gone. Right? And this area is not exactly, Iran, Turkmenistan, and Russia. There is not exactly uh, civil peace in this area. It's kind of some big unrest, to say the least, in this little area. And when people talk about there's going to be water wars next, this is one of the reasons because the countries in these areas, and even in the United States, are losing their water a little bit faster than we would hope they would. So the drying of the Aral Sea has led to a loss of about 60,000 fishing jobs, blowing of the pesticide land dust from the dried lake bed. It has polluted a lot of the area around the Aral Sea, and there's been a loss of most of the cotton production because lo and behold, they don't have any more water to feed their plants and the crops. So groundwater, which is in aquifers, okay, is being depleted more easily than surface water because we don't really see it. Okay, we can't really, uh, you know, there's no really stopping us. And whose water does this belong to? All right, so if a farmer here in Nebraska can pump out as much as he wants, all right, and who's to say that he can't? Okay, as the aquifers are mined, the water table drops, and the Ogallala Aquifer in the Great Plains has been drawn down by more than 320 million liters. Right? What is going to happen to the breadbasket of the world when this great watering source for all of our irrigation goes bye bye? Right? We need to, Mother Nature has a certain clock of rainfall, and then that rain running into the water, and we need to have that, live within inside those limits. And right now, we are not living inside those limits. So when the groundwater is over extracted, in coastal areas, salt water from the ocean can intrude. And this is what's happening in Florida. They're getting what's called saltwater intrusion. So, Florida is a peninsula, right? So it's a landmass surrounded by three sides, a body of water on all three sides there. And when that bottom part of that part of Florida, about half of Florida on the bottom part, no longer can be gotten to or have that freshwater aquifer anymore because it's all saltwater intrusion because we're drawing it out too fast. All right, and this does not happen normally because it is being pushed back by the fresh groundwater flowing into the sea. So it's no, normally if we did it right, we wouldn't have this problem. All right, but from the over withdrawal, that's how the salt water is getting in, and it's actually sucking some of that stuff in too. So the coastal regions in California, Florida, India, Middle East, and now even coastal wells are drawing up saline water instead of the fresh water. And this is the water way down there in the bottom of the well. All right, so we have to drill down deeper and deeper and stick the stuff down. And down at the bottom, over the millions of years, all the sediment and all the salts and all the chemicals and all that stuff settled down at the bottom. And now we're taking that straw all the way down, and we're kind of sucking this stuff up, and mixing it up, and making that aquifer unhealthy for us to actually drink. So as aquifers lose water, they become less able to support overlaying stratus, causing land surface to subside. So this can be cause buildings to lean, large areas of land to suddenly collapse, creating what's called a sinkhole. I don't know if you guys, there was this guy in Florida who was in his house, and a sinkhole enveloped his house, and they still have, I don't know if they ever found that guy. He just fell right into the hole and disappeared. Okay, because that land mass is usually, here's the land mass right here, and then we got a little U shape with the water, and the water's holding up all that land up top. All right, and when we suck that out, it leaves that little air pocket, and then when the trucks run over or a house is on top, it eventually gives up, and that's how that sinkhole is actually created. Another thing in the water industry is controversial is the bottled water, and it's becoming a booming business with about $160 billion in annual sales. And it's been sometimes, water has been more expensive to buy a gallon of water in these little, jugs than it is a gallon of gasoline sometimes. Bottled water has has a major ecological impact, with energy costs about 1,000 to 2,000 times greater than tap water, and about 1.5 million tons of plastic wasted or generated annually. Right, and I think that's a waste of the plastic, in my humble opinion, because we got reusable cycles and faucets out there to be able to do this thing. All right, and the water is actually no different than what you're actually drinking from the tap water. If you read your back of your water thing, it says it comes from a municipal source most of the time. All right. So flooding is a process that occurs when snow melt or heavy water swell and the volume of rivers, so it spills out over the riverbanks. And in the long term, floods are ecologically beneficial and spread the nutrients and sediment over large areas. So floods are very important to the ecological system, all right, of getting all that fish emulsion that's been on the bottom of the rivers out there and to flood the floodplains and make all that good agriculture grow, all right, or the forest grow, whatever it's flooding into. In the short term, floods are damaging to the property of people who live in the floodplains. And a lot of our U.S. citizens actually live in a floodplain. And when you get a house, you have to get it, you get it surveyed of wherever you're living. And if you're living in a floodplain, you have to get flood insurance for that. All right. And it's becoming more and more expensive because the floods are getting worse and worse because we have more precipitation in the atmosphere due to global warming, and that precipitation is coming down in greater amounts. So to protect against these floods, we put up what's called levees, and they're built along the banks of the water to hold away the water in the main channels. And this is what is all over Louisiana with the New Orleans, right? They have a whole bunch of levees holding back because they're already underneath water, believe it or not. And those levees, when those levees break too, that could be a big disaster like we saw in Katrina. So artificial rivers called aqueducts or canal and channel waters for our water from rivers to lakes to homes and farms. All right, so we have a lot of aqueducts and canals out there in the United States. They've worked out pretty good for transportation and things like that. Florida has a lot of great areas to go hang out, and you just drive up to your house in your boat, and it's been really nice. But we've realized that some of these aqueducts and canals have caused more problems than harms. Right. The Colorado River, for example, was diverted to provide water to Denver, Las Vegas, Los Angeles, San Diego, and farmland throughout the Imperial Valley. And that's why the Colorado River is sometimes draining or drying out before it even gets to the ocean, is because each state needs to take out a little bit for its agricultural and industrial use. All right. So we also have what's called dams, which are obstructions placed in the river system to block its flow. Dams created what's called reservoirs. We keep that water behind the dam there so we can use it to drink out of course, but also we use mostly a lot of our dams for electricity, electrical generation. And the dams help prevent floods too and provide drinking water, irrigation, and generation. So here's a big old dam. Everybody's seen the Hoover Dam. Well, we got Lake Medak here behind it. You got your boating and recreation and a nice little area so we can get a little bit of farm irrigation going on. And, got a casino over here for Las Vegas. And then we have our electricity coming out. So the Three Gorges dams in China was the biggest one ever done, and it cost about 39 billion to build. And the reservoir flooded 22 cities. All right, so when they built this, they took out 22 cities, farmland, habitat, well, displaced about 1.24 million people, all to build this dam. All right, 39 billion cost, and plus all these cities were lost, and the farmland and the habitat, and the 1.24 billion. So I don't know how much this was. This is in dollar values. It's got to be a lot. All right, and deprived coastal marshes and sediment, causing them to erode away. So there's been some big problems, and this thing just kind of got built. I mean, it was just built. I think it got commissioned about 5 years ago, maybe 5, 6 years ago. And this year they had it almost broke due to some heavy rains. So that would be a good current event. Go look up the Chinese dam. Put in Chinese dam almost broke in Google machine, and it almost broke this year. That would have been a disaster because there's a lot of people that live below this dam. There's a lot more than 1.24 million people below the dam that would have been devastated by that flood of water coming down there. So those who argue that the cost of dams outweigh the benefits promote the idea of dam removal. All right, so because some people say that these people shouldn't lose their homes, and dams are doing more bad than good, and we want to remove them, and they want to restore the ecosystem to the natural ways, and we're doing a lot of this in Florida with a lot of our waterways, all those tributaries that they've diverted into the canals and aqueducts that they have down there. They want to reestablish the fisheries, revive river recreation such as fly fishing and rafting, and return shellfish and fish habitats in and around the mouths of the rivers disrupted by the dams. All right, there's roughly about 400 dams that have been removed around the United States in the past decade because they have not been as beneficial as we thought they would be. So, solutions and depletion for fresh water. So, population growth, expansion of irrigation, and industrial development have doubled our use of fresh water over the past 50 years. So, we have doubled our use of fresh water, humanity has. All right. Addressing water shortages means either increasing supply. All right. Somehow we got to find some more water out there, or whether we get that from the ocean or from wherever, or reducing demand. And what we try to focus on most of the time is reducing demand. And here in the United States, we've actually done that pretty good. We haven't really reduced demand per se. We just use the water more efficiently. All right, so we have those low flow shower heads and efficient washers and dryers, and or just washers, not dryers, or dishwashers. We also have drip irrigation for agriculture. So we have the technology to be able to do this. But a lot of people, a lot of this uh, doubling of the use of fresh water has been in other areas because that's where the population's really growing. Remember, in the United States, our population is basically at zero population growth right now. So we can also desalinate the water, remove the salt from the seawater and other places. The salt can be removed by we heat it up and evaporate it, and it's called distillation and filtering through a membrane of tiny pores that trap the salt. It's called reverse osmosis. So desalination is very expensive and uses a lot of energy and generates all the salty waste that we don't know what to do with. Okay. Saudi Arabia, though, gets most of its drinking water from desalination. So does Israel. Does a lot of this desalination um, for their populations. Okay, but it's very, very, very expensive to do. Since agriculture makes up the majority of the water demand, it is logical to place start conserving. Uh, and we have done this a lot. I mean, the agricultural industry does actually try to conserve water a lot because they have to pay for it nowadays. All right. There's actually, I heard there's going to be what's called water futures. You can buy oil futures on the stock market, or natural gas futures, or cattle futures and hog futures. All this great stuff, wheat, soybeans, and all these different commodities. Right. Well, guess what? They're going to come out with a water future. Okay. And we're not just be putting a price on the water. All right. And we want to be able to price that properly. And what's better way to price it than in a free market, efficient marketplace like the stock market, right? But there's technologies that we use, all right, to help reduce our efficiency. So the lining irrigation canals to prevent leaks, all right, leveling fields to minimize the runoff. So I got to make sure that our crop fields are properly graded. All right, moving from inefficient irrigation methods like flood and furrow, where you're just flooding the field from a little rock in the stream over here, lift it up and flood everything out there, to more efficient like drip irrigation. All right, drip irrigation works really good. All right, that's an actually a really uh, new way, but an efficient way because it goes right to the uh, roots of the plants. All right, eliminating water intensive crops from arid regions. So plant the crops that actually grow the native plants. All right, we shouldn't be growing um, almond trees in California where we grow them. All right. Yes, the temperature is great, but the biome's precipitation is not good enough for trees, and it takes up a lot of water to grow that almond milk for us. Okay. So water can be used to reduce. Can be water can be reduced in households by installing low flow faucets, shower heads, and all those and wash machines. All right, we got the Energy Star labeling that goes on, and you have to buy certain kinds of shower heads nowadays. That I don't even think that they have high flow shower heads left in the world anymore. Okay, those things just don't really exist because it's not inefficient. I'd say just why waste the money, right? And you still get a nice, powerful shower head. All right, using alternative sources of water for gardening and lawn care to help reduce homes' footprints. All right, you put up some rain barrels, rain waters. All right, or you can put into what's called a gray water system, which uses the water from the showers and sinks that can be used in some place for watering. So you take out the gray water and you put it into your lawns, into your lawn sprinklers. All right. There's also exterscaping, which is landscaping using plants adapted for arid conditions. So, just native planting. If you plant your native plants where you live, guess what? You never really have to water them, right? They just, they're born to live there to begin with. So industry can also save water by shifting into processes that use less of it. So municipalities can also recycle treated municipal waterways for irrigation and fix leaks in the pumps and reduce all that water loss. So there's a lot of things that both industry and governments can do to fix all their little drips in their faucets. Nations often cooperate to solve water disputes. So there's been fears that the unequal access to fresh water and worldwide could lead to conflict between the countries. And yes, there has been a lot of conflict between the countries because you can see here mostly in the arid regions. All right, you got a lot of conflict, but there's also um, conflict here in the United States as well. Okay, where we have some disputes. Florida, Georgia, and Alabama have been in the lawsuit for about 5 years now, or 13 years now, about getting water from the Lake Mead out there. Okay, so it's not just all these countries trying to, arguing about where the water's coming. But in total, about 261 major rivers cross national boundaries, making disagreements common. So far, many of the nations have cooperated to resolve their disputes. India, for example, has struck agreements with Pakistan and Bangladesh, Bhutan, and Nepal to co-manage the transboundary rivers. All right, so they're working together because they know that it's a precious resource that all their citizens need in order to survive. So, in addition to over withdrawing water, people can affect aquatic ecosystems by inducing toxic substances to the disease-causing microorganisms. So, despite the major improvements in recent decades, the World Commission on Water recently concluded that about half the world's water major rivers remain seriously depleted and polluted. All right, so about half of all waters out there, major river systems are polluted. And water pollution includes any changes in chemical, physical, or biological properties of the water due to human activities. Okay, so we have to have a chemical, physical, or biological properties of the water have to change to human activity. So we put lead into the water, that would be a chemical. Physical, we remove it, right? Or change it to, I don't know how you change it physically. But biologically, we introduce some pathogens into it. We put in some um, microbes, some kind of microbes that eat on the bacteria that we drink and then get sick. So there's many impacts of water pollution that are not visible, such as pH, all right, which is acidic level of the water, nutrients concentration. Okay, that's when we have the anthropogenic algae blooms. All right, dissolved oxygen when there's no oxygen in the water due to that algae bloom, it all dies off and then gets eaten by the bacteria in the bottom of it's eating the old algae, and they say they must be chemically monitored. All right, so we need to actually watch these waterways, and that's what we do. We go around and we monitor the different waterways out there to make sure that they're safe for us. And we also have what's called point and non-point source pollutions when it comes to water and actually also air pollution. All right. So point source pollutions are discrete locations that release the water pollution. So we can see the drain, the pollution running out the drain right into the water. Right. Non-point source solutions are as multiple endpoints over large areas. So we don't know exactly which farm caused the algae bloom, which city street where that oil came and contaminated the sewage system, or which resident neighbor put the chem lawn on their lawns that polluted the waters. Okay, so there's a lot of different areas. Right, so a point we can actually see. All right, non-point. It could be any one of these houses, any one of these farms, right? Any one of these boats, but we can see the big tanker, of course, right? But there's a lot of different boats that run up and down here, and some of them might have get some diesel in the waterway. Okay, so many types of toxic chemicals are released into the water sources. We got pesticides, we got petroleum products, we got heavy metals, we got acid, uh, and acid precipitation, and mining runoff. So acid from acid rain gets into the waters, and also from the mines, from the coal mines out there. Disease-causing organisms and bacteria and parasites get into the drinking water supply from sewage out there. All right, this is happening a lot in Alabama. All right, there's a lot of sewage, improper sewage treatment, and kids in Alabama are coming up with some of the third world uh, parasites in their bodies from drinking some of that polluted water, and that's here in Alabama. So, biological pollution by pathogens cause more human health problems in any other type of water pollution. And the UN estimates about 3,800 children die daily of cholera, dysentery, and waterborne diseases. So there's 3,800 children are dying a day due to waterborne illnesses. Nutrient pollution from fertilizers and other sources causes that interpretation and hypoxia that we talked about in Chesapeake Bay. Um, and algae is fertilized, causes an overgrowth of blocks sunlight and needed the underwater plants, and the algae dies off, becomes decomposed, and it depletes the oxygen level, just like we learned in the bay. And one of the biggest ones is dead zones that happens every year is out here in the Gulf of Mexico. All right, so we got the Mississippi River running off in here, all right, and all that water running into all the farmland, and it gives this big, huge algae bloom. And every year, this dead zone in the Gulf of Mexico gets bigger and bigger. Every spring, it starts forming, and then by the big summer, it's huge. And every year it's getting bigger and bigger. But then, during the wintertime, the runoff and the stuff stops flowing down here from the fertilizers. Farmers aren't fertilizing anymore and stuff like that. And the waves break this up and bring back the oxygen, all right, making this dead zone smaller and smaller. It still stays a little bit in some little areas, all right? But lo and behold, next spring, it all happens once more, all right? And it gets bigger and bigger every single year. So excess nutrient concentrates can lead to harmful algae blooms, like we talked about. Human waste and animal manure and paper pulp mills also cause these algae blooms to happen. All right. Um, these also they not exactly an algae bloom, but they go out there and then the same bacteria that are eating these algae blooms are eating this human waste and animal manure and paper pulp as well. All right, causing the lower oxygen level. So it's the same animal, just a different feedstock for them. All right. Wastewater is water affected by human activities and includes water from toilets, sinks, dishwashers, and washing machines. So sediments are eroded soils carried by the river by runoff and transported long distances. All right, and we usually see these sediments coming after we've done clear cutting or doing some mining or something like that. After we've levied the land and taken away, taken out all the trees and all the good stuff that used to hold that soil there. We also have had a lot of oil spills. They are infrequent, but when they happen, their impact are staggering. We had the Exxon Valdez in 1989. Was still trying to clean up from that. And one of the most recent ones was Deepwater Horizon back in 2010. Okay. And you can see this is the oil spilled from the tankers, right? We've got 28,000 here from Atlantic Emirates, all right? See where it was Exxon Valdez with 37, all right? These are just the tankers, all right? This is not, I think Can't remember how much Deepwater Horizon was. It doesn't tell us on it. So I can't remember how much it was. It was a ton, though. It was a lot more than that. And it was just a oil rig that was just spilling. It was kept on spewing oil out. And they couldn't cap it because it was on the bottom of the ocean. Nuts. I don't know how long, if we ever going to clean it from that Deepwater Horizon. We also have discarded a lot of water pollution from our trash, right? So we have discarded fishing nets and fishing lines and plastic bags and bottles, all right? I already talked about the Great Pacific Garbage Patch, which is an area in the Pacific which the plastic outnumbers the plankton. All right, you too can do this little experiment. You can go out there and scoop up a little bit of water out there, and you'll find that you find more plastic than plankton. And it's about a 6-to-1 ratio. And it's because that gyre out there, the ocean currents, picking up all the stuff over here on the Pacific, coming around over here to China and stuff, and it gets everything caught in this little area. And it just all collects there. Great Pacific Garbage Patches. But most pollution control measures have focused on surface water, but groundwater is also vulnerable to pollution. But it's a lot harder. Remember, these are the aquifers, the water that's underneath our feet we can't really see. So to be able to, clean that out, it's going to be almost impossible, right? We don't really have any microbes down there to, sunlight, and we can't really have some life forms to help clean it up and all that. But we can, pump it out, clean it, and then pump it back in, maybe. Who knows, right? So, but that would be really expensive. We got to have the storage. We get all the water out of there. So, over withdrawal of groundwater concentrates the pollutants into that are present as well. All right. So, since we're pulling more water out, and there's less and less water, that is going to be less dilution of all that, all those poisons in there. All those, because remember, it's generally considered safe principles, right? So we look at generally considered safe stuff, and it has to be so many parts per million. And when we have less parts per million, less water in there, and that means that we're going to have less parts per or more parts per million because there's less water. So it's going to be more concentrated in that area. So certain chemicals such as aluminum, fluorides, and nitrates and sulfurs occur naturally in groundwater due to its contact with rock. So it's not all bad stuff. It's in there, all right. But human sources, including leaking underground storage tanks and leaching of solvents and pesticides to the soils, have increased these and added other things that would never be in this water to begin with. So more than 1/3 of the underground tanks housing radioactive waste in Hanford Nuclear Reservation in Washington are leaking into the groundwater supply. Right? So 1/3 of the underground tanks of radioactive waste. And we can't clean that water up once it's all radioactive. So water pollution has been reduced greatly, though, in the passage of the Clean Water Act of 1977. It set the standards of contamination levels, which generally considered safe and all that stuff. That's when we got the EPA and all that great stuff out there. The Great Lakes of North America are one of the biggest success stories. The toxic chemical levels have been reduced by about 71%, phosphates by about 80%, and chlorinated pollutants about 82%. So we've done a really good job of cleaning up our lakes and our rivers here in the United States after we had the Clean Water Act. But remember, we wanted to make them swimmable and fishable, all right? Not drinkable necessarily, okay? And we've done that. We really have done that, and I got to give us kudos for that. And I think we've all enjoyed the benefits or reaped the benefits of that program, all right? Before reaching tap water, we treat our drinking water. So before reaching the tap, our water from the reservoir or aquifer is treated with a bunch of chemicals to remove a bunch of particulate matter, filtered by sand and gravel and charcoal, just like Mother Nature's filters into that water aquifer. All right, disinfected with a little bit of chlorine, and then tested for levels of about 90 contaminants based on standards set by the EPA, the generally considered safe standards of the EPA. But that's only 90 contaminants, and there's a lot more contaminants out there nowadays that we need to start looking at. Okay. In rural areas, though, septic tanks separate the solids and oils from the water and septic tank, and the water travels downhill through the gravity-filled trenches where they can be naturally decomposed. In urban areas, the treatment facilities will perform primary treatment, physical removal. All right, so our waste. This is about our wastewater. So, um, our urban areas treat facilities and perform primary treatment. So we've got the secondary treatment, which stirs and aerates the water. Then the effluent, which is treated and kills the bacteria and returned back to the rivers. And the remaining biosolids are used as fertilizers. All right, and with just a simple old process. All right, where the water comes down through the system. And you guys might have seen these big old tanks that stir up the water, and then it oxygenates it. All right, and then it goes through some more clarifying, and then filtering and disinfection. All right. So emptying into the oceans. Of all the human impacts on the ocean, overfishing may be the most pressing. All right. As many fish stocks have been severely depleted. So more than half of all marine fish populations are fully exploited right now. So half of all marine fish populations fully exploited, meaning any further harvesting will be unsustainable. That we won't have any fish left. Despite increased fishing efforts, global harvesting levels leveled after about 1998. All right. And current trends continue. The collapse seen in the cod industry in eastern Canada and New England may be repeated in all the world's fisheries. So we saw a huge collapse in the cod industry in Canada and New England. And, we're just not fishing there anymore. We had to shut it down. But if we're not smart, a lot of our other fisheries are going to go that way. And we can see that the global fishery catch here it's kind of leveled off, all right? But we've actually included aquaculture, all right? And I think we talked about aquaculture. Let's just go and fish in a bunch of fish tanks, all right? Talked about that in the agricultural section, okay? Which is nice, all right? So we have this to back us up on, still get some fish, okay? But we need to keep this level right here and actually decrease it so some of these fish populations come back, and then we're able to fish them again, all right? But industrialized fishing has facilitated this overharvesting, okay? Because we use different seamings and drift netting. We can actually fish all the fish out of the sea if we wanted to. Just drag a whole different net. And it's indiscriminate. It doesn't really pick out just the salmon or just the tuna or whatever. It picks out all the fish out here. Okay? You're hoping just to get a whole slew of different ways of catching. Right? So we got the long laying, the trawling. Okay? We can just fish out the whole ocean. And what happens is we get a bycatch. And this accelerates the capture of animals during the industrial fishing. And about 17% of all commercially harvested fish were captured unintentionally. Okay. Pursuing and drifting at captured dolphins, sea turtles, and seals end up drowning and dying from exposure on the deck of the ship. All right, long line fishing captures turtles and sharks and albatrosses. So the bycatch bottom trawlers can destroy entire benthic ecosystem. So there's little shells down there in the bottoms. Okay. In 2003, a study showed that the oceans today contained about 1/10 the large fish and sharks they once did. So we've lost 1/10 of what we've had out there. Many fisheries have collapsed, including Atlantic cod and red snapper. Fishing fleets have been fished down the food chain and shifting to smaller and smaller desirable species. All right, so we're eating worse and worse fish. Okay, we got to eat some of those fish that are invasive species. Right, we got to start eating all that jumping carp nowadays. So fishery management managers use surveys of fish populations and study to monitor catching of fish to regulate the timing, scale, and techniques of used in harvest. So we've done a lot of good jobs trying to uh, implement sustainable, what's called sustainable fishing practices. So you might have seen the deadliest catch on TV, where you're only allowed to go out um, at a certain time of the year, only allowed to catch so many different fish, all these different things. So, despite these efforts, fish stocks have continued to crash. This suggests that an ecosystem based management system is needed. So, we really got to think about the whole ocean and not just worrying about the individual fishes out there. We got to stop fishing in the whole area, bring back the coral, and all this other stuff that's happening in the oceans because if the oceans collapse, man, we're going to be in big trouble, in my humble opinion. But that is just me. Marine protected, we have what's called, to do this, we put up what's called marine protective areas. All right, that restrict some human activity like oil drilling, but also allow fishing and other extra activities for some ecological tourism and things like that. All right, but 3% of all ocean waters have this designation, so it's not a big part of the ocean out there. It's only about 3%. I think the biggest one was done, I think, by George Bush Jr. All right, before he left, he made a lot of the parts in Florida uh, a ocean water reserve, right, or marine reserve. So marine reserves are areas in the ocean where fishing is prohibited. All right, commercial and recreation fishers dislike these areas, but scientists argue they can be served as productive factories for fish in the surrounding areas. And what the fishermen do in these protected areas is they just go, right to the edge and drop their lines, and they bang them. All right, they really do catch a lot of fish because the fish are going to run in and out of that little protected area. They just got to make sure that they don't drift into that protected area. In 2001, data review revealed that the marine reserves on average provide about the following benefits: about a 23% increase in species density, a 91% increase in organism density within the reserves, 192% increase in total biomass in there, and about 31% increase in the average organism size. All right, the mortality and habitat damage are also reduced, and the larvae of a species inside the reserves seed the sea when they spread in there to other areas outside the reserves. All right, so there definitely are some definite benefits to these protected reserves. Finally, part of this, and we're going to talk a little bit about climate change. And climate change is actually altering the ocean's chemistry. It is making it more acidic. All right, it's starting some what's called ocean acidification because the oceans are absorbing this carbon dioxide, making it difficult for the shell and absorbing this carbon dioxide, increasing the pH level, the acidic level of the oceans, and then making it difficult for the shell forming animals to make their shells and produce shells. So they don't have any bodies anymore. Right? These shells also start to erode faster as they are made once the concentration hits a certain level. All right, so they're having trouble making them, and then once they hit a certain level, they just disappear on them. Okay, and this ocean acidification is really scaring the scientists because we don't know how to change the pH of the oceans back to the way it was. All right, because that's a lot of water to regulate for when it comes to the pH. All right, I know I went through that one a little bit fast there, my friends, but I also didn't want to do it into two different subjects. Okay, so I hope everybody has a good evening, and we will talk to you next week. We'll start with renewable energies, or no, fossil fuels next week. All right, thanks everyone. We'll see you. Bye bye.